In modern sport, the difference between fame and meaninglessness can be a fraction of a second or a few centimeters. In that intense environment, some athletes, coaches, and even medical staff are tempted to use drugs and methods that promise an edge, while an increasingly sophisticated anti-doping system works to detect and deter them. In this module, we will explore 4 key learning outcomes related to the prevention and prevalence of drug use and abuse in sport. First, we will look at statistics on doping control and ask what they really tell us about how common doping is. Second, we will examine how drug misuse can occur through medical practitioners, particularly in the routine use of legal medications such as painkillers. Third, we will discuss why it is so difficult to estimate the true prevalence of drug misuse among athletes. Finally, we will analyze the legitimacy of drug testing itself, its scientific basis, its limitations, and the ethical tensions it creates. Real-world data and examples from football, athletics, endurance events, and other sports will illustrate how complex this landscape really is. The World Anti-Doping Agency, WADA, coordinates the global anti-doping system and publishes annual testing figures summarizing all samples analyzed in WADA, accredited and approved laboratories. In 2023, laboratories reported 289,000 samples analyzed worldwide, a 12.5% increase compared to 2022, when 256,000 samples were analyzed. This total includes urine tests, blood tests, and increasingly, dried blood spot samples, reflecting an effort to diversify testing tools and make doping harder to evade. Of these nearly 289,000 samples, about 239,000 tests were conducted on athletes in Olympic sports and roughly 50,000 tests in non-Olympic sports. These numbers represent a massive operational system. Hundreds of samples collected, transported, processed, and reported each day under strict chain of custody and quality standards. The scale, cost, and complexity of this system are central to understanding how anti-doping works in practice. Within these hundreds of thousands of tests, only a small fraction yield problematic results. WADA's statistics distinguish between adverse analytical findings, or AAFs, and atypical findings, or ATFs. An AAF is a laboratory result that shows the presence of a prohibited substance, its metabolites or markers, or evidence of a prohibited method. However, an AAF does not automatically equal a sanctioned doping case. There may be therapeutic use. Exemptions, or later legal and scientific review, may change the outcome. ATFs are suspicious or unusual results that do not immediately qualify as positive. They often trigger follow-up testing or further investigation. When we combine AAFs and ATFs, we get the total proportion of samples that require additional scrutiny. In 2023, the proportion of total findings, AAFs plus ATFs, was 0.96%, up from 0.93% in 2022. The proportion of AAFs alone increased from 0.77% to 0.80% of all samples. In other words, fewer than 1 in 100 tests produced an AAF. Within Olympic sports, around 1 in 300 positive tests out of 239,000 samples corresponded to roughly 0.57% AAFs, with ATFs bringing the total proportion of problematic samples to about 0.73%. In non-Olympic sports, the proportion of problematic samples was substantially higher, about 2.07% of tests. When students see positive rates around 0.5–0.8%, it can be tempting to conclude that doping is rare. But these figures require careful interpretation. First, testing is not random. It is targeted toward higher-risk sports and athletes, which should increase the chance of catching dopers. Second, sophisticated doping practices, careful timing, microdosing, use of short-acting substances, are designed precisely to avoid detection. Third, legitimate medical use under therapeutic use exemptions complicates the picture, because some apparent positives may be permitted in context. Most importantly, independent research using anonymous and indirect surveys often finds much higher rates of admitted doping or suspected misuse than suggested by the official testing statistics. This gap between detected cases and estimated behavior is central to understanding prevalence and prevention. A German study comparing 3 sources of prevalence data illustrates the discrepancy. For German elite athletes, official testing pointed to a doping prevalence of about 0.81%. When athletes were asked directly about doping, only 0.2% admitted it, an implausibly low number that likely reflects fear and social desirability bias. But when researchers applied an indirect survey method, designed to protect anonymity more strongly, estimated prevalence jumped to about 6.8%. Other studies using indirect methods have reported even higher estimates. One analysis found that direct questions yielded 7.8% admitted doping, whereas an indirect method suggested that 42.5% of athletes had doped. In that sample, estimates were around 58% among bodybuilders and 32.7% in other athletes. Across at least 19 studies using different indirect models, estimated doping prevalence has ranged from 0% up to 58%, with most indirect estimates substantially higher than positive test rates. All of this suggests that official testing statistics represent only the visible fraction of doping, the tip of an iceberg whose true size is difficult to measure. The COVID-19 pandemic disrupted sport calendars and reduced out-of-competition testing. As events resumed, testing volumes not only returned to pre-pandemic levels but have now surpassed them. WADA's 2023 report emphasized that test numbers reached an all-time high, signaling a broad return to full anti-doping operations. External analyses of WADA data show that in 2023 there were around 2,300 adverse analytical findings and about 2,000 sanctions, representing increases of roughly 16% and 20% respectively compared with the previous year. Whether this reflects more doping, better targeting, improved detection, or some combination of these factors is a matter for careful interpretation. Looking at individual sports, we see large variations. Some federations in low-risk or precision sports report very few tests and almost no positives. Endurance sports, combat sports, and certain power sports, by contrast, show higher testing intensity and higher rates of positives, sometimes confirmed by investigative journalism that reveals suspicious blood values and suggestive of doping patterns that do not always result in sanctions. The key teaching point is that anti-doping statistics must be read in context, by sport, by level of competition, by testing strategy, and within the legal and scientific framework that governs what counts as a violation. Doping often evokes images of steroids, erythropoietin, and blood transfusions. Yet in everyday sports medicine, a more common pattern is the heavy use of legal medications, especially painkillers and anti-inflammatories, under the influence of team physicians and medical staff. Some of this use is clearly justified by injury or illness, but much of it sits in a gray zone, where drugs are used prophylactically, routinely, or aggressively to keep athletes on the field, rather than for clear medical indications. Medical practitioners can therefore act either as gatekeepers who protect athletes or as enablers of drug misuse. The way they prescribe and counsel can normalize certain drugs as an expected part of elite performance. Football provides one of the best documented examples. Since the 2002 FIFA World Cup, team doctors have been required to report all medications given to players in the 72 hours before each match. Analyses of World Cups between 2002 and 2014 show a consistently high prevalence of medication use, particularly non-steroidal anti-inflammatory drugs, or NSAIDs. Across these tournaments, around 69% of players used at least one medication, and more than half used NSAIDs. Up to 1/3 of all players took an NSAID before every match, regardless of whether they actually played. In some squads, players were reported to be using more than one NSAID per match. One striking example involves the drug allopurinol. Normally used to treat gout by lowering uric acid, it was prescribed to about 40% of the players on one team during a World Cup, reportedly in the hope of reducing skeletal and cardiac muscle damage. This is a clear case of using a medication prophylactically in healthy athletes based on hypothetical performance-related benefits rather than standard clinical indications. These patterns raise important questions. If 1/3 of players are taking NSAIDs before every match, but injury rates are lower than that, What exactly is being treated? Are these drugs being used to cope with chronic overload, fatigue, and soreness, effectively becoming a routine part of getting ready to play? High medication use is not confined to elite team sports. Studies of recreational and sub-elite runners in mass events, such as the Bonn Marathon 2009, the Berlin Marathon 2010, and the El Andalus Ultramarathon, have found that between 47% and 61% of participants used NSAIDs or other analgesics in association with the event. The health consequences can be significant. In one study, athletes who used NSAIDs had almost 5 times more adverse events than non-users, including gastrointestinal cramps and bleeding, hematuria, and cardiovascular problems such as arrhythmias and palpitations. There were serious cases, such as oliguria or anuria, in runners using ibuprofen, and multiple instances of gastric bleeding in those taking high doses of acetylsalicylic acid. Many such athletes take these drugs without direct medical supervision, relying on advice from peers or marketing claims. But even when physicians are involved, the risks may be underestimated, especially under the pressures of competition and performance. These examples highlight the central role of medical practitioners. Team doctors and sports physicians can act as ethical gatekeepers, prescribing only when clearly indicated at appropriate doses, and with clear communication about risks and alternatives. They can discourage routine pre-match NSAID use and ensure that medications are not used simply to mask pain and push through injuries. However, in high-pressure environments, medical staff may be pushed, implicitly or explicitly, to keep athletes available at all costs. In those situations, prescribing patterns may shift from treating injuries to facilitating performance. When entire teams are given prophylactic NSAIDs or off-label drugs like allopurinol, the line between legitimate care and performance-oriented drug use becomes blurred. This dynamic is particularly relevant to prevention. Drug misuse in sport does not always start with an athlete seeking an unfair advantage. It can arise gradually from a culture in which aggressive medication is considered normal, and where medical staff feel they must do something to protect their reputation and satisfy coaches and management. NSAIDs are the most visible example, but far from the only one. Reviews of drug abuse in athletes have described misuse of opioids, stimulants, and sedatives in professional sport contexts. In one study of professional American football players, 52% reported using opiate painkillers at some point in their career, and 71% of those considered their use to have been misuse at some time. Chronic pain, repeated injuries, and pressure to play can create a pathway from medically initiated pain management to dependence and abuse. Sedatives and sleep medications may be prescribed for jet lag, travel, and anxiety around competition. While not always prohibited substances, their routine or off-label use, especially in combination with alcohol or other drugs, can become a form of misuse that affects both performance and long-term health. The key message is that the boundary between appropriate treatment and misuse is defined not only by legality or anti-doping status, but also by clinical indication, dosing, duration, and the underlying purpose for which the drug is used. Preventing drug misuse through medical channels requires evidence-based prescribing, avoiding routine or prophylactic use of NSAIDs, opioids, and other drugs without clear indication, internal guidelines and audits, reviewing prescribing patterns, standardizing protocols, and requiring justification for high-risk drugs. Athlete education, ensuring that athletes understand the health risks of casual or chronic medication use, especially during strenuous competition. Independence of medical decision-making, insulating doctors from direct performance-related pressure from coaches or management. Transparent medication records, documenting what is prescribed, why, and in what dose, and reviewing these records for signs of misuse. When physicians maintain a conservative, athlete-centered approach, they form a crucial line of defense against both overt doping and the everyday misuse of legal medications. Estimating how many athletes misuse drugs or dope is challenging because the behavior is inherently hidden. Official anti-doping statistics, with positive test rates below 1%, capture only those who are detected. Survey-based estimates, especially when using indirect methods, often suggest much higher levels of doping and misuse. The discrepancy arises from methodological limitations, behavioral incentives to conceal use, and technical constraints on detection. Doping is not a visible behavior. It is a secretive practice that athletes know is punishable and stigmatized. The simplest survey method is to ask athletes directly, "Have you used banned substances?" But direct questions suffer from social desirability bias and fear of consequences. Athletes may doubt that their anonymity is truly guaranteed, or worry that confessing could damage their career even if no sanctions are imposed. As noted earlier, one study found that only 0.2% of German athletes admitted doping under direct questioning, even though official testing suggested a prevalence of 0.81%. It is highly unlikely that fewer athletes would admit doping than are caught by tests. Instead, this reflects strong reluctance to admit wrongdoing, even in research settings. To improve candor, researchers use indirect techniques such as the randomized response technique and unrelated question models. In these designs, each respondent follows a random procedure that determines whether they answer truthfully or give a predetermined answer. The researcher knows the probabilities but not each individual's status, allowing group prevalence to be estimated while protecting individuals. These methods have produced much higher estimates of doping prevalence. In one instance, direct questioning yielded 7.8% admitted doping, whereas an indirect method estimated 42.5%. Over many studies, estimated prevalence ranges from 0% to 58%, with indirect estimates consistently higher than testing data. However, indirect methods are not a magic solution. They rely on participants understanding and following the instructions. If some athletes always answer no, regardless of the randomization, the estimates can be biased. Recent work has pointed out that non-compliance is the Achilles heel of these methods, and that prevalence estimates must be interpreted cautiously, with explicit checks for non-compliance. Another challenge is that most studies focus on specific sports, events, or countries. Prevalence among bodybuilders and power athletes is unlikely to mirror that in archery or gymnastics. Sample selection, for example, recruiting athletes via federations, teams, or online platforms, can also introduce bias. Athletes who choose to participate in doping-related studies may differ from those who refuse. For these reasons, we should be skeptical of sweeping statements like X% of all elite athletes dope. It is more accurate to talk about prevalence within particular contexts, with clear acknowledgement of sampling limitations. Testing-based prevalence estimates are further undermined by pharmacological strategies designed to avoid detection. Many substances have short detection windows. Carefully timed dosing cycles allow athletes to benefit from drugs while testing negative. Microdosing, using small amounts frequently, can reduce detectability even further. Certain methods, such as autologous blood transfusions, are inherently difficult to detect directly because they use the athlete's own blood. The athlete biological passport, which tracks markers like hemoglobin and reticulocyte count over time, can reveal suspicious patterns, but scientific and legal thresholds must be met before an abnormal profile is judged consistent with doping. Investigative reports citing leaked blood data in athletics have found many samples that looked suggestive of doping, but did not lead to sanctions, typically because the evidence fell just short of the required legal standard. This illustrates how much may remain hidden, even in heavily tested sports. Finally, cultural factors affect both behavior and reporting. In some sports or countries, doping may be widely perceived as common, yet athletes rarely admit it. In others, strong anti-doping culture and internal norms make any form of pharmacological enhancement taboo, which can suppress both behavior and disclosure. Stigma, fear of being labeled a cheater, and concern about reputational damage all contribute to underreporting, even in anonymous surveys. On the other side, rumors and suspicions may exaggerate perceived prevalence. This mismatch between perception and evidence complicates prevention efforts and public communication. Given the limitations of each approach, experts advocate using multiple sources of evidence, testing statistics, direct and indirect surveys, biological data, and qualitative interviews to build a richer, triangulated picture of drug misuse in sport. Testing data provide concrete, verifiable numbers about detected violations and trends. Survey methods reveal the possible scale of hidden doping and variation between sports. Qualitative research and journalism offer insight into motives, methods, and cultural context, sometimes uncovering systemic issues that numbers alone cannot show. Even with triangulation, we will not arrive at a single precise prevalence figure. Instead, we obtain ranges and scenarios that are useful for policy and education, while openly recognizing uncertainty. Drug testing is central to the perceived fairness and integrity of modern sport. It serves not only to catch cheaters, but also to deter potential dopers, reassure clean athletes, and maintain public confidence in results and records. Without some form of testing, many people would assume that everyone dopes, undermining the value of performance and competition. Testing is justified by aims such as fairness, health protection, and respect for rules. However, it also imposes significant burdens on athletes: surveillance, loss of privacy, and the risk of being sanctioned even in complex or borderline cases. The legitimacy of drug testing depends on how well it balances these competing values. The credibility of testing rests on its scientific foundations. WADA-accredited laboratories must meet strict accreditation standards, undergo regular proficiency testing, and use validated methods. The athlete biological passport adds a longitudinal dimension, tracking biomarkers over time and flagging abnormal patterns that may indicate blood manipulation or steroid use. But all methods require decision thresholds, cutoff values above which a result is considered positive. If thresholds are set too low, false positives may increase. If too high, dopers may slip through. Establishing and defending these thresholds scientifically and legally is an ongoing challenge. Under the World Anti-Doping Code, athletes are strictly liable for any prohibited substance in their samples, regardless of intent. This principle simplifies enforcement and encourages vigilance. But it also leads to difficult cases where athletes test positive because of contamination in supplements, medications, or even food. In such cases, athletes may still be found to have committed a rule violation, though sanctions can be reduced if they prove no significant fault or negligence. To do so, they must identify the source of contamination and show that it plausibly explains the result, a demanding burden of proof. High-profile contamination cases have fueled debate about fairness and consistency. Some argue that strict liability is necessary to maintain deterrence, while others say that it can punish athletes who did not intend to cheat and could not reasonably have prevented exposure. These tensions directly affect how legitimate athletes perceive the testing system. Legal standards for anti-doping decisions are stringent. At the Court of Arbitration for Sport, panels often require a very high probability, approaching certainty, that a positive result is genuine before upholding a sanction. In cases involving more complex markers, such as human growth hormone or blood profiles, tribunals have sometimes concluded that the scientific basis for a decision threshold was not strong enough, even when results looked suspicious. One documented example involved a cross-country skier whose blood values were likely the result of cheating, but the panel ruled in his favor because the decision limits for the test were not sufficiently validated. These decisions can frustrate anti-doping officials and clean athletes, but they also underline the importance of rigorous science and due process. If thresholds are poorly justified or methods rushed into practice, wrongful sanctions could occur, undermining trust in the entire system. Legitimacy depends on both catching real cheaters and protecting innocent athletes from unjust accusations. Critics argue that testing misses many dopers, pointing to the low percentage of positives and major scandals uncovered through police investigations, whistleblowers, or leaked data rather than routine testing. Leaked blood databases in athletics, for instance, revealed numerous results suggestive of doping that had not led to sanctions. On the other hand, testing clearly does catch some cheaters and appears to have deterrent effects. Increasing numbers of tests, sanctions, and retroactive positives from stored samples suggest that sophisticated methods can eventually be uncovered. The knowledge that samples may be retested years later may discourage some athletes from taking risks. For teaching, it is important to acknowledge both sides. Testing is imperfect and sometimes reactive, but it is also a powerful tool that has evolved significantly and continues to improve. Its legitimacy depends partly on whether athletes believe that cheaters face a real and meaningful risk of detection. Anti-doping measures go beyond laboratory analysis. Elite athletes must provide detailed whereabouts information, often specifying a daily 1-hour window for potential testing, and must submit to sample collection under direct observation. These requirements raise serious questions about privacy and bodily autonomy. Access to medical records, long-term storage of biological samples, and extensive data collection in the athlete biological passport add further layers of intrusion. Some argue that athletes, as professionals, consent to these conditions. Others note that many enter elite sport as teenagers and may have limited real choice. Debates over data protection, consent, and the proportionality of surveillance are central to the ethical evaluation of anti-doping programs. If athletes perceive the system as invasive, opaque, or biased, its moral legitimacy may suffer even if its technical performance is strong. Looking ahead, the future of drug testing will be shaped by both technology and governance. Technologically, advances in analytical sensitivity, biomarker discovery, and omics approaches may allow earlier and more reliable detection of subtle doping practices. Wider use of dried blood spot testing could make sample collection more flexible and less burdensome. In governance, greater transparency, clear handling of contamination cases, robust protections for whistleblowers, and meaningful athlete representation in decision-making bodies are all important steps. At the same time, prevention and education must address the deeper drivers of doping and misuse, such as unrealistic performance expectations, economic pressures, and inadequate care for athletes' mental health and long-term well-being. Ultimately, the legitimacy of drug testing rests not only on catching cheaters, but also on demonstrating that the system is scientifically sound, ethically defensible, and applied fairly. For students of drugs in sport, understanding these nuances is essential for engaging with real-world debates and designing better policies. In this overview, we have examined 4 dimensions of prevention and prevalence in drugs in sport. We saw that global testing statistics show hundreds of thousands of samples each year, with less than 1% yielding adverse or atypical findings, yet survey-based research indicates that actual doping and misuse rates are likely far higher. We reviewed how medical practitioners can either protect athletes or unintentionally enable misuse through routine prescribing of NSAIDs, opioids, and other medications. We explored why estimating the true prevalence of drug misuse is so difficult, from methodological issues in surveys to pharmacological strategies that evade detection. Finally, we considered the legitimacy of drug testing, balancing its vital role in maintaining fairness with its scientific limits, legal complexities, and ethical costs. For anyone working in sports science, medicine, coaching, or policy, these issues are not abstract. They shape how we design prevention programs, how we advise athletes, and how we interpret performances and records. A nuanced understanding of statistics, medical practice, measurement challenges, and the ethics of testing is essential if we are to respond intelligently to the persistent challenge of drugs in sport.